Okay, this is concept number 6, which is prime factorization and simplifying square roots. So a couple definitions first is what is a prime number? And it's a number that only has two different factors, one and itself. So you can't break that number down any further. There's no other values that will multiply to give you this value as an answer. So some examples are 2, 3, 5, 7, 11, 13, 19. Again, it's numbers that, if you think about 19, there are no two numbers that can multiply together to give you 19 other than 1 and 19. So it's a prime number, same as 13. There is nothing that's going to multiply together to give you 13 other than 1 and 13. Okay, so those are your prime numbers. Prime factorization means that you're breaking down a number into all of the prime numbers that will divide evenly into there. Okay, so prime factorization just means you want to find all of the prime numbers that belong to that value that you started with. A factor is a number that divides evenly into another number. So, for example, if we were looking at the number 10, okay, factors of 10 are 2 and 5, okay, because those two values multiply to give me 10. Okay, so it's any number that can divide evenly into that value is considered a factor of it. Okay, so if we're going to write the prime factorization, we have two examples here. On this first slide, I have 24, so you start breaking it down. It doesn't have to be that you start with 2 times something to break it down. You can begin breaking this down however you want. So you could start with 4 times 6. You could start with 3 times 8, 12 times 2. Whichever way you want to start it is perfectly fine. You will get to the same prime numbers at the end. So here we started breaking it down by 2 times 12. That 12 breaks down further into 2 times 6. The 6 breaks down further into 2 times 3. Now, these numbers that are left over that have not broken down are my prime numbers. This here is just the work. Okay? You have to write the prime factorization by now, taking those prime numbers, and we normally go least to greatest. So my smallest prime number that I have here is 2. Okay? I have 3 of those 2's in my prime factorization, so it's 2 to the 3rd power. Okay? I had 3 2's. So it was 2 to the 3rd power. Then I also had a single 3. There was only one of them, so it's just times 3, technically to the 1st power, but you don't need to have that exponent there. So the prime factorization of 24 is 2 to the 3rd power times 3. Again, you would have gotten to that same prime factorization regardless of how you started to break it down. Okay, so you don't have to start with 2. Then if we did a prime factorization of 100, so in this case we started with 2 times 50. Then 50 breaks down to 2 times 25. 25 breaks down to 5 times 5. So now to write that prime factorization, again, if you go in order from least to greatest, it kind of makes it the easiest so that you don't miss any numbers. But if I start with my 2's, I had 2 of them, so it's 2 to the 2nd power. I have 2 5's that are left over as prime numbers, so it's 5 to the 2nd power. Okay, so you're just writing it in exponential form with the base and the exponent showing how many of these values you had. So these two pieces here are your prime factorization. That's your final answer. This factor tree that we made is just the work to get you there. 2 more examples. Over here, 195 breaks down into 5 times 39, then 3 times 13. Smallest to largest, 3. There's only one of them, so it's just 3 times 5. There's one of those, times 13. Okay, so those are all just to the 1st power, which is perfectly okay. Same thing with 120. You can follow through the work for breaking it down. I end up with 2 to the 3rd power, because I have 3 of them, times 3 times 5. All right, now when we get to square roots. Square root, the definition is a number that is produced by taking a number and multiplying it by itself. So for example, 4 times 4 is 16. So working backwards, the square root of 16 is equal to 4. And when you're finding the square root of a number, you are trying to find what number times itself will give you that value. So the square root of 16 is 4 because 4 times itself would give you 16. Perfect squares are 2 integers multiplied by themselves that gives you that value. So in this case, 16 is a perfect square. because I do have a number times itself that will give me 16. 3 times 3 is 9, so 9 is a perfect square. Here is listed all of the perfect squares from 1 to 225. So 1 is a perfect square, 1 times 1 gives you that. 4 is a perfect square, 2 times 2. 9 is a perfect square, it's 3 times 3. 4 times 4 gives you 16. 25, 36, 49, 64, 81, 100, 121, 144, 169, 196 is 14 times 14, and then 225 is 15 times 15. 13 is not a perfect square because the square root of 13 is not an integer. So remember, perfect squares are only values that a number times itself gives you that answer. Okay, so the square root of 13, there's no number times itself that is going to give me 13. All right, now, steps for simplifying square roots. Okay, these are the steps that we're going to go through when we start simplifying them. First step is to make the factor tree, which is exactly what we did up here for the prime factorization. So it starts out the same as the prime factorization. Okay, you make the factor tree. Then you want to circle all pairs of prime numbers in your tree. Now remember, pairs means 2 of those values, so pairs is 2 of them. Pull out one number from each pair that you circled. If you're pulling out more than one number, you're going to multiply them together. Okay, everything with square roots is going to be multiplying. You're never adding values together here. We are multiplying. Anything that pairs up that you are able to take one of those values gets written on the outside of the square root. Then any prime numbers that are left over that could not be paired up get placed back underneath of the square root. Okay. So anything that is circled that gets paired up gets pulled to the outside. Anything that is not paired up gets put back on the inside of the square root. All right, so let's look at some examples. We want to simplify these square roots. So I'm starting with the square root of 8. Okay, so I just start with the factor tree, I break it apart. Okay, the only way to start the square root of 8 is to break down that into 2 times 4. Then that 4 breaks down into 2 times 2. Now at this point, I'm done. I have all prime numbers left over. So we are looking for pairs of the same value. Now remember, pairs are groups of 2. So I have a pair of 2's right here. That gets paired together, which means a single 2 gets written on the outside. Then this 2, which was left over, didn't have anything to pair it up with, gets put back into the square root. So I just have 2 times the square root of 2 for the simplified version of the square root of 8. Now, best way to check these. Type in the square root of 8 into your calculator, then type in 2 times the square root of 2 into your calculator, and you should get the same decimal value. If you do not, then you definitely made a mistake and you need to go back. So if we look at square root of 30 then, break it down into 2 times 15. Okay, you could start breaking it down into 3 times 10 if you wanted to. It does not have to be this breakdown. Okay, you will still get to the same exact prime numbers at the end. But in this case, we did 2 times 15. That 15 breaks down into 3 times 5. Now, I have all prime numbers left over here, but none of them pair up. I don't have a pair of the same values here. I don't have any other 2's to pair that with. I don't have any 3's to pair that with. I don't have any 5's to pair that with. Which means it's already simplified, which is okay. Okay? If there are no pairs to circle, then it's already simplified. That's as far simplified as it can be. Okay, so you can, 2 things for your answer. You can either write already simplified, or you can just rewrite the square root exactly how it was to begin with. Okay, either answer is acceptable. All right, some more examples. Square root of 90. We started out by breaking it down into 2 and 45. Then the 45 breaks down into 5 and 9. Then 9 breaks down into 3 times 3. Now that you have all prime numbers left over, you're just looking for pairs of the same value. So the 3's pair up and become a single 3 on the outside. The 2 and the 5 don't have anything to pair up with, which means they have to get put back underneath of the square root. So I have a 3 on the outside now, a 2 and a 5 on the inside, which have to get multiplied back together to give you the square root of 10. Now again, check your answer. Type in your original problem, the square root of 90, into your calculator. You get 9.49. Type in 3 times the square root of 10, which was our answer, and you will get the same decimal. Okay? They have to be the same value, or else it's not simplified correctly. 180, break down into 2 times 90, then 2 times 45, 3 times 15, and then 3 times 5. Okay? Pairing up your values. These 2's can be paired together. That gives me a single 2 on the outside. These 3's get paired together, which gives me a single 3 on the outside. And I still have a 5 left over, which means that has to get put back underneath of the square root. My numbers on the outside, that 2 times 3, you have to multiply back together to get 6. So I have 6 times the square root of 5. A couple more examples down here, and you can follow through the work for them. Square root of 36, and you can start breaking it down. 2 times 18, 2 times 9, and then 3 times 3. So when you pair these up, your prime numbers of 2's pair up and become a single 2 on the outside. Prime numbers of 3 pair up and become a single 3 on the outside. There was nothing else left over here. We were able to pair everything up that was prime numbers. When that happens, that means that nothing gets put back under a square root, so you don't even have a square root with your answer anymore. Your final answer here is just 6, which makes sense because if you think back, the square root of 36, this is a perfect square. Remember, perfect square means what number times itself gives me 36. That value is 6, which is the same exact answer you got from breaking it down. So if you recognize that this value underneath of here is a perfect square, you can skip the work and you can jump straight to the answer of 6 if you recognize that. If not, it's okay. You can still go through the work. It's only going to take you a minute to do that, and then you will still get to the same answer either way. Now, this second example here, we already have a negative 5 on the outside, okay, which hasn't happened up to this point. All the other ones only had values on the inside. That's okay if there's already a number out there. You have to save that to the end. So you may want to circle it so you don't forget about it, or rewrite it down towards the bottom of where your work is going to be so that you don't forget about it. Okay, you're just going to save that to the end and then deal with it then. Still break down this value inside of here first. So 2 times 36, which breaks to 2 times 18, 2 times 9, and then 3 times 3. So you find your pairs just like normal. So I paired up these 2's, which become a single 2 on the outside. Paired up these 3's, which become a single 3 on the outside. Then I still have this extra 2 that's left over, so it gets written back inside of the square root symbol. Now, these get multiplied together, your 2 times 3, and give you a 6, but don't forget, you still had a negative 5 that was originally out there. So that negative 5 has to get multiplied by your other values that you brought outside of there as well. So you end up really having negative 5 times 2 times 3, which is going to give you a negative 30, and then you still have your square root of 2 left over. 2 more examples here that follow through the same exact work. So you could follow through them, but again, they both have a value on the outside that you have to remember to carry to your answer. All right, again, this is your concept number 6, which is prime factorization and simplifying square roots.